Good afternoon, ladies and gentlemen, here in New York City. Thank you for joining us for the next general session. We're on day 2 of International Cloud Expo. Good morning, good afternoon, good evening if you're joining us out there on the World Wide Web on our live stream. Steve Sicola is up next, which means we're talking Xiotech. He is going to tell you where the Xio comes from. You must promise me you'll tell them that Xio, because I like that origin. He's going to tell us about data storage in the cloud, which is what we want to hear, so I'm going to get off the stage and leave it to you, sir.
Thank you very much. Thanks for having me here today. Thank you. Goodness sakes. Well, I just passed my 32nd year of doing storage. It's not something they really teach you in college, and I would say that probably that needs to be taught based on some of the things I've seen in the world over the last few years. And basically, if you don't know me, some of you may have seen my bio and whatever. I've been doing this, I started at Digital Equipment Corporation back in '79, working on the first array controllers for, I'd say VAX clusters, the first cloud there might have been. I can remember 50 VAXs inside of a room with a whole bunch of what they called HSCs doing, all of the data for AT&T, multiple data centers across the country back in the days in the 80s. And then actually started this little thing called StorageWorks at Digital and did all the StorageWorks arrays all the way through the EVA. And back in 2002, we started a brand new division of Seagate with my entire team, which is pretty interesting because they're all kind of like gray like me with a few youngins and such. Basically started a new technology thing with a $100 million investment, because that, believe it or not, that's how much money it takes to build a brand new disk drive in this industry. But the whole focus was to come up with how would you get the most reliability, the most performance, the most availability at the highest capacity efficiency possible out of a group of drives, and come up with a new architecture that would last 10, 20, 30 years. And that is what is called, what we've called ICE. But it really is about, getting ready for what at that time was called the grid, or ready for the cloud. So that's my thing with my lineage. My team's been together for 30 years, developed about 300 and some odd patents, and the technology that you can see out in the booths is something that's based on those 88 patents in one thing. But what I want to talk about today is, you talk about in the presentation, talks about the myths and the realities of storage for the cloud, and obviously basically getting to it specifically here with this presentation. It's about data storage. What does it really mean? Balancing performance, capacity, and cost. And I think with that, I'll get into it, because you can see me later this week to talk, and you've got information about what we're doing, and I'll talk a little about that at the end. But it's interesting when you talk about the cloud. In a lot of cases, most data does follow a similar pattern. You write it, you read it, and a lot of it, some of it, you ignore it because you've got to keep it online forever because of government regulations, et cetera, and or people have, done too much with it and decided to forget about it, et cetera. But it's interesting that small amounts of data, in my experience, it's been, small amount of data, follow a much more aggressive pattern where it's you write, read, write, and that depends on that level of data, and it changes over time because you're running a business on it. And this world of a cloud is something to where you're all about automating your business processes and trying to come up with something. In a lot of cases, it's a private cloud, could be a public cloud, but I've seen most public clouds being used for backup purposes, automating processes across the web, bring up security issues, et cetera. But a lot of people are interested in saying, well, what if I implement a private cloud? What's that mean? But in order to make a good result, you talk about the result for, and I'll say it here, result is for an effective cloud storage. You need to have both high capacity and high performance. What's your ratios depends on what your business needs. And it's interesting when you look at it overall, it says it needs to be cheaper than done in-house, but in a lot of cases you're doing private stuff it's still in-house. You're ready to say what you've done in the past, it needs to be cheaper than. So it's interesting that a lot of times I think traditional cloud implementations that have been done have been thought of as more of a data dumping ground, where it was all about the dollars per gigabyte and nothing else, and performance was irrelevant. And I think your biggest cases of this are things like Google or other things like that really went after it with a vengeance, with using essentially desktop drives and a lot of let's say totally commodity servers, even below the higher performance servers. But you can say cloud storage is really becoming a lot more active. I mean, because people want to run their businesses on it. Google was based on a model of, content, where people are going to grab it, a lot of sequential access, a lot of things like that. And you can tell I'm a techie because this is not a marketing thing. I know where all the bodies are buried in this industry from a long time. But when you talk about, things like file synchronization or what they call big data is lots of unstructured data and calendars and things like that. A lot of this stuff is, more active than you would have thought before. But that's because businesses are starting to think about how to do this. Because in my mind, cloud is really about automating all your IT processes and trying to pull it all together. It was what I think people tried to do, but then a lot of greed got involved with the whole promise of consolidation of storage with SANs and things like that. But it's interesting that performance is still needed for cloud computing. And the whole point is, if you can't do it faster and cheaper, it's not going to win. And a lot of the stuff, it's not just about, and I'll talk more, I've got another presentation more that gets a little bit more technology oriented tomorrow afternoon that really gets into it. But it's basically saying if you can't do it faster and cheaper, it won't win. That's interesting. How does that play? But if you look at it, it's an interesting, we'll call it an unfortunate side effect of capacity growth. And that is the time that it takes to actually read a whole drive has gone up incredibly from back in even the year 2000. I can remember in year 2000, it was always this big thing of like, I can remember going to Bankers Trust, which then became Deutsche Bank, and they're basically asking, wow, we got these 9 gigabyte drives. I don't know, man. We can't even use all the performance on these. We can't get all the data off these things very quick, and we're going to 18 gigabyte drives. Well, where are we at now? We're at like 2 terabyte drives, and it takes like 100 minutes or more. You realize that to just do a format on a 2 terabyte drive, or like say a 3 terabyte drive, takes about 11 hours. I'm like, shoot me, This is like, how do you put this together? And doesn't get just solved by things like SSDs either. So it's interesting. We talk about this over the last 10 years. On a performance per gigabyte basis, drives have gone down by 50x. Well, that's because things like, you can't spin them that much faster, because the power goes up by a square of, in terms of how fast you spin them and stuff. You can't do that. You can't burn out your things. You got to save room for all those servers that burn a whole lot more power than storage. Servers are the most awful thing. I mean, you can almost create thunderstorms with how much power those things build in a data center. But when you look at it, it's really interesting. You talk about an enterprise drive, and I guess I could ask this. I'll ask it again tomorrow. First of all, how many people here think all disk drives are the same? Well, that's good. How many people know the difference between a desktop or a nearline drive or an enterprise drive? Do you know all that? Because it's pretty interesting that I would say a lot of people, especially, depends on what you learn in college, because when I was in college, I didn't have to learn so much about powers or transistors because I'm an electrical engineer, computer architect, the whole works. But nowadays you kind of start where you left off and go further. It's like the Italian guy in a movie where it's like, looks in the rearview mirror and rips it off. What's behind me, I don't care. That helps you make less assumptions about things, but actually sometimes it makes you make more assumptions about things, which is bad, because the difference between a desktop drive or a nearline drive or an enterprise drive is night and day in terms of how long you can use them, how quickly they're going to wear out, and how much performance you're going to get. So you take an enterprise drive. An enterprise drive, an Exchange server with 125 users at 2.4 gigabytes per user. That's what it can handle. And that's depending on everything being perfect. In a lot of cases, a lot of arrays and things like that can't even get out of their own way to get the performance. So that means you can't get out all your data. Or a 300 gigabyte database with 12 transactions per second. Oh, that's not a whole lot of transactions when you think about this world. That's what one drive, that's an enterprise drive. You think of a desktop drive that can get like 1/4 of that, and that's like, the difference between a buggy with a few wheels in a simple car, or a virtual desktop with, say, 3 users at 100 gigabytes per user. That's what one enterprise drive typically can handle. And the interesting part is it's all about the capacity performance numbers that vary. They're totally imbalanced, against the performance piece. And internal IT, this is an incredibly wasted expenditure. You have a ton of data out there that you have no chance of getting IOs to. I can't tell you the number of IT guys I talk to that have big sets of data that they're like, yeah, we got half this stuff we can't even get to. You know, if we tried to, it's like we just have to cycle through it and do whatever. And, you know, this is interesting stuff because you talk about it being a wasted expenditure. For anybody doing a cloud, this is something that's unobtainable revenue because you can't get IOs to it. You're basically lost. So sometimes you have to do a write down or do whatever. This seems pretty nuts, right? But this is, in a lot of cases, how a lot of things have been done. When you look at Google, they've done stuff with a lot more servers per like a few SATA drives and stuff. They still can't get data to all those drives, but they're assuming that people aren't going to do that. They're getting at a little bit of content here and there. That's not the same as running a business, you know, or running a cloud that needs to have stuff right away. For part of it, it is, and that's great for archive if you can keep them alive and reliable. So the interesting part, there's worse things. We talked about that performance on a drive. All the stuff that you do on all of your storage out there for all these lovely features that all of us array vendors did over the years because Microsoft and Linux, Windows and Linux came about to take away all the proprietary stuff that had all these features built into the server until now with things like VMware and all these other software packages out there. All the arrays did stuff with snapshot, thin provisioning, and dedupe, not compression, that's different. Traditional tiering, and I mean tiering in terms of things like going from you know, your DRAM to maybe an SSD now, but in general to enterprise drives to high cap drives. And generally housekeeping. All this stuff just kills your performance. So all those numbers you talked about of what a drive could get, forget about it. You may get like a quarter of that. Therefore, you have even less amount of your data you can get to in any kind of real-time purposes. That's awful. Now, the promise is there if storage doesn't really have to do all that, and you can get into things. And that's where you see some of the new things coming from, you know, whether it's Windows or VMware or whatever, all these guys doing packages that actually put some of those features back in the server, including things like, we didn't talk about overall replication. That takes time, you know, for disaster tolerance. Because you still got, if you got a cloud, you still got to replicate the whole thing. It's completely crazy. So the whole part here is about, you know, you got to understand the whole system to be able to put together stuff. It's not just about the entry cost. So it's interesting, when you talk about traditional tiering, you know, it's a great example of sacrificing performance for capacity because tiering focuses on capacity. It is the classic example of HSM. HSM is a word that's gone from, let's see, HSM migrated to ILM, which now is to tiering. HSM is just hierarchical storage management. Stuff flows downhill. It's not meant to deal with how things move in a real-time basis. And it's interesting, all of the current tiering algorithms that are used out there for people that are now talking, because I've seen a lot of stuff here and I've seen it over the last couple of years, you know, they're especially bad for heavily loaded environments. And that means a business. A business has loaded environments that need performance now. They may have peaks and valleys and they don't want to have to reprovision because it kills them. Any kind of an event for reliability or availability stuff just kills them and they're losing millions of dollars every second. That's way different than your like backup cloud. That's okay. That might be the replacement for tapes eventually, you know. But you think, you know, think about satellite navigation before you had traffic information. It gives you stuff, but it really doesn't necessarily help when it comes to the real, you know, bottlenecks out there. So it's interesting. You look at performance. Let's say how you look at it. Enterprise storage may give you, give an example of a system that might give you 10,000 IOPS. When you get to archive storage, it only gives you maybe 2,000 IOPS if you're lucky. And that's a big deal because archive storage is different. That's where you talk about the different usages of different disk drives, the right disk drive for the right kind of workload. I mean, enterprise drives are meant to be used 24/7 by 365, and an archive storage is meant to be used 8 hours a day max, especially if you use a desktop drive. Use any more of that, you're going to kill it. But that means you're really not focused on performance there. And what's performance? IOs are one thing, but bandwidth is another. Anybody can get bandwidth, and if you're just doing sequential stuff, you're great. But one thing you may not have thought about is a whole bunch of sequential workloads to archive storage turns into a random workload, which kills the drive. Everything is all that way. And you'll see some interesting effects that happen with solid states if you follow what I've done. So it's interesting. current tiering solutions are fine if you just want capacity, but if you need any kind of performance at all, you're going to be stuck. You're going to be paying a lot more, because what ends up happening is that, but it's one of those things. But if you just wanted capacity, you wouldn't do tiering, right? So it's kind of like you're almost getting sold extra stuff that you didn't need. And that's what a lot of people want you to do. They want you to buy these licenses so you can do all this stuff, and then it turns out you didn't need it. Then you got to buy more to make up for it to have performance. So how do you fix this performance? The obvious thing is just buy more disks and stripe the hell out of it. And it's fine if you don't use the capacity. This reminds me of a long, long time ago with people that still do it in like seismic operations and things like that have actually moved to full SSD when it's totally critical. They used to just stripe drives and just use the inner part of all the drives and waste all the other space. That's pretty much what people have to do in this business to basically get performance with traditional systems that have been out there. And even with SSDs, they'll say, well, you just need more SSDs because you have to have more of your stuff on higher expensive stuff. Increase the performance per disk. Cache, it works sometimes, but there's always a limit, and cache costs a heck of a lot more money than, DRAM, than spinning media or something that architecturally knows how to make things work right in the different tiers. Better understanding of drives. I've been able to consistently over the years get more IOs per drive than anybody, but there's a lot of people out there. You got to look at the numbers and understand what it means. When you buy an array controller or buy a system, it'll say, I can handle 1,000 disk drives. Well, where does it fall over? That's 100 disk drives. Well, that means you shouldn't be selling me stuff if I can't use all of it, unless you really only need part of the data. So, and intelligent data placement algorithms. If you know where the data is going to be, it's great. Back in the day, and I guess that's probably before I had gray hair, systems used to tell storage where things were coming and where things, it was called hints. All of that stuff went away in the open systems market. And it's completely gone when you think about open source kind of stuff, because they're making assumptions that they own everything and the storage is completely dumb. Storage doesn't have to be dumb when it comes down to it, if you're just not trying to put every feature on the planet in it. Intelligent data placement has been the key. When storage started figuring out how to do effective caching algorithms for read cache and write back cache and all this kind of stuff, it took the load off of these operating systems, because the operating systems don't have any non-volatility. They can't handle stuff when power goes down, all these other little things that come into system operation. Because if you don't know the system, you start making assumptions to say, I can't assume anything there, I'm just going to use the cheapest stuff here and there, which ends up saying I have the cheapest solution to start with, but I have the most expensive solution to maintain forever and ever, and it's also not very green either. You're going to start throwing away stuff when it breaks. So it's interesting. You look at cloud test suites that people have out there. Cloud test suite, may provide a clean copy of every current version of Windows. Desktop server, all valid combinations, something that might automatically upload a program and run the tests, stores results in a centralized and then destroys the VM, something that creates it and builds it and puts it away, kind of like, the commercial of a Visa commercial. But it's interesting, with all of something like this, performance is the enabler. Everything that I talk about here is what happens with people that might want to do a cloud, because it's all about virtualization. Virtualization of the servers. Virtualization of the application, virtualization of the network, virtualization of the storage. Every one of those things comes down to the bottom level, which is the storage. And it's interesting, with the cloud or your IT, storage is the most important part of your business, because if you don't have your data, you have nothing. And that's why people take great pains to do it. And I would say that you should really think about how this works, because the time taken to create and destroy a VM is the cost that it takes us, to cost the service provider and not the customer, because they can't charge a customer for that stuff. That's overhead. So the quicker they can do that, and that comes down to I/O, how you do it. And doing I/O in a way that allows you to have the fault tolerance and the availability without having to create a solution around something that might be faster that's not shared. So the whole thing, if they can reduce that amount of time in a significant way at lower cost, it makes the service provider be able to make that much more money, and to the customer, you're going to end up reaping the benefits of this, because you're going to pay less. Because believe me, when they say you can't charge it, they're still charging it. It's always the little extra thing they won't tell you about. But it's always the time taken to run the test is also a fixed rate. So if you can reduce the amount of time that an application takes to run a test suite or whatever, the better it goes. You know, you can run more people on it. That's the whole advantage of being able to virtualize things to save the money, is to be able to do more with less and do it. I said efficiency is the key, and this also ends up reducing power. The whole works if you do it right. So it's interesting. Closing thoughts, and I'll add some more comments here. You know, stop thinking like it's 2000. For me, it's almost like back to before 1990. I mean, it's interesting. If you go back to 1990, we were at the end of what I would say the proprietary server and storage game, and what that meant was you had servers that were pretty good, not nearly as performant as now, but you had disk drives that were reasonably reliable, and they could be used all at the same time and be run 24 hours a day. Versus today, if you see the different models of building a cloud, the most prevalent is what I've seen out there is a lot of people are saying, well, let's just throw together a ton of drives, you know, desktop drives, and use open source software and all this other kind of stuff, and because it's the absolute cheapest thing to put together, and I can put together petabytes of this stuff. If you want performance out of that, you have to gang together a zillion of those drives to make it work right. Therefore, and they also then have to have multiple copies of the data. A lot of times they have 3 and 4 copies of the data because they don't want to do RAID. Well, wait a minute, 3 to 4 copies of the data is RAID. It's RAID 1 back from 1990, damn it. And that's totally backwards from what, you know, it's going back to the dark ages of whatever. It's like we did something really good, and then we lost the recipe because people lost how to build systems and saying RAID is bad. Well, the only reason people don't like necessarily RAID is they're getting charged licenses for everything, service for everything, and it ends up saying enough is enough, and they start questioning why they did it, versus looking at the whole system and trying to look for solutions that might be a lot more efficient, you know? And it's interesting, measure anything other than archive storage in terms of performance, not capacity. You want to be able to get IOs to all of your bytes that are out there. In this case, terabytes and petabytes, because the data is not stopping. You know, archive for data, for records and things like that, that's great. Backups, you know, to be able to restore later, all that kind of stuff, that's great. You're not going to touch it. But you also, even for archive, you need to think about how's this stuff going to stay reliable. I'll give you an example. You know, to me, a SATA desktop drive is just like a tube from a TV. I worked with the physicists and all the people that did the first computer for the Navy. I was like an 18-year-old kid seeing these guys that had worked on this stuff, and they told me stories. They're like, yeah, we made this thing work, and it had thousands and thousands of tubes, and, you know, they've seen the picture, it filled this room. And they made it all work. But once they did it, it died about every hour because a tube died. And they had to go hunt around and fix around what the heck's going on. And that's the same thing you get with SATA drives. So there is a difference between stuff, and you can't get performance out of them, you can't get reliability. And this presentation talks about mainly about performance, but reliability is huge here when you talk about it. So interestingly enough, also be wary. And this is just a, you know, be wary of things that supposedly capacity increasing and performance decreasing features, you know, added value features, and all this stuff that I talked about, snapshots and dedupe and all this other stuff. You not only reduce performance, you reduce reliability. As I said, you do multiple sequential streams to a cheapo drive, you're going to kill it. I can kill a SATA drive in 20 minutes in my lab. It's pretty easy. You just heat them up, and it's interesting. People think, aren't all disk drives the same? I mean, I was actually up a little place up near Seattle asking the software guys, and some of these guys were like, oh yeah, they're all the same. And I'm like, oh my gosh, there's a complete massive difference between these drives. There's a usage for them, but even with me, I wouldn't necessarily use SATA. I'd end up using, you know, SAS with all the SATA mechanics, so at least I had dual port drives, you know, and how do you do data integrity? So there's so much stuff, so I would, you know, certainly leave it in terms of, with me, I think I'm just about done. But questions, I can take some questions, but I want to give you some more comments. I would ask the question of, you know, a lot of you do in IT, whatever, it's all about where have all the systems people gone in this world? You got to look at the whole problem. So, question. Great, thanks. How much time do I have, Jeremy?
Well, we're sort of there, but it's such a good question that it's worth it.
Okay, good.
Steve, that was really great.
Thank you.
You mentioned something about using commercially available cheap SATA disks. aggregating them into a sort of massive storage,
Mm-hmm.
and that apparently has some performance impact.
Mm-hmm.
Can you elaborate more on that, please?
If you try to do, it's interesting, you can achieve performance by ganging together zillions of drives, but you pay for it one way or the other. And the whole world of being able to gang together stuff, it's like, what price glory, right? If you were to gang together 4 drives that burn, say, half the power of an enterprise drive to get the same performance of an enterprise drive, okay, you just took twice the space, you cost pretty much the same, and you ended up taking twice the power. So it ended up costing you more money when you thought that you didn't. Not to mention they're less reliable, so you're also going to make more of the garbage heap. So you can do it. It's just a matter of what you can do with other stuff. Really, the reliability is a big thing, plus it burns power. And like I said, we put a man on the moon 40 years ago. We can do RAID right if people focus.
We're going to thank you because we have another session hard
Thank you.
after you. Steve Sikola, let's say thank you, please.